All right, 6b.3 is classifying triangles by using coordinate proofs. So a coordinate proof is a proof that uses slope, midpoint, and distance formulas. So a proof that uses slope, point, and distance formula to prove something, right? So we're going to be proving something. In this section, we're specifically going to be proving what types of triangles something is. So I can prove that a triangle is scalene, I can prove that it's isosceles, or that it's equilateral. First, we need to know what those words mean. A scalene triangle is a triangle that has where all three sides have different lengths. An isosceles triangle is a triangle where at least two sides have equal lengths. So you only need to show that two of the sides have equal lengths to prove that it's isosceles. And then equilateral triangle is all three sides for the purpose of this class, we are going to say that an equilateral triangle is also an isosceles triangle. Because it does, if all three sides have the same length, then at least two sides have equal lengths. But if it's asking you to be specific, right, classify it as specifically as possible, or classify the triangle, and it is equilateral, then you should say that it's equilateral. But if you're proving a triangle is isosceles, then it's equilateral, then it's also isosceles. So it won't come up too much, or if at all. But just something to keep in mind. All right, let's look at example 1. So in order to prove or classify our triangle, we need to know the length of the sides. So we're going to use that by using the distance formula, but we're not really using the distance formula, we're using Pythagorean's theorem, right? So if I'm finding the length of this side, I'm just going from one point to the next. Just like we did with partitioning, slope, all of that, right? So it's a lot of just going up and over. So this, now this creates this triangle, right? So we have 2, 1, 2, 3, 4, 5, 6, 7, 8, and x. So to find x, right, we're doing 2 squared plus 8 squared equals x squared. Equals x squared. If you want to get it as a decimal, that's fine. But to be honest, you're just trying to determine if the things are the same or not. And so we'll kind of see how, if I know, okay, that's square root 68, I can kind of just leave it like that and see if the other ones match up. Okay, so let's find our next side. I'm going to go from this point to this point. It does not matter the order that you do them in. Right? So this is what we're looking for. I know this one is 1, 2, 3, and this one is 1, 2, 3, 4, 5, 6. So that's 3 squared plus 6 squared equals x squared. Plus 36 squared. Right. I don't need to know the decimal to know that the square root of 68 is not going to equal the square root of 45. Right. That's all I mean. Like, you don't have to simplify it or put it in decimal form or anything. I can tell from there those are not equal. And then our last triangle, or our last side, right? Going from here to here, we're finding this length. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Four squared is 16, plus 5 squared is 25. Adding, take the square root, so that's 41. So, square root of 68, square root of 65, 45, square root of 41. All three of those are different, so that makes this a scalene triangle. All right, looking at our next page. Example 2, classify the triangle as scalene, isosceles, or equilateral. Yeah. We just have to find all three sides. So we can start with this one, going from here to here, go up 2, over 2. So 2 squared +4 plus 4. So our first side is square root of 8. So we can put it in there. Our next triangle, our next side, going from here to here, we go over 1, 2, 3, and then down 1, 2, 3, 4, 5. So this side is the square root of 34. Then on our last side, right, going from here to here, this side is 5, right? 1, 2, 3, 4, 5. Then 1, 2, 3. So I could do, kind of doing 3 squared plus 5 squared equals x squared. But look, this is the same, so we should just be able to jump to that x is the square root of 34. All right, I don't need to see the same work twice. All right, so if that happens where you can see that it's the same numbers exactly, then you know those sides are equal. So then this one has two sides that are the same, so it is isosceles. All right, last problem. Classify the triangle as scalene, isosceles, or equilateral. So this one, the first one's actually really easy because it is just going across the bottom. I can just count, right? This one, 1, 2, 3, 4, 5, 6. So that's nice. My next side, right, going from here to here. Ah. Ah. Alright, so we're going up 1, 2, 3, 4, 5, and over 3. So we have 5 squared plus 3 squared equals x squared. X squared, adding those, 30. I don't know why I did the square root earlier. So 25 plus 9 is 34. Take the square root. We get the square root of 34. On our last side of the triangle, from here to here, we go over 3, down 5. Look at that, it's the same thing. X equals the square root of 34. So these are similar, or these are the same, where that's 6. So again, 2 sides are the same, so this is an isosceles triangle. Alright, that is it. I'll see you guys tomorrow. Have a good rest of your day.